Hey guys, welcome to Unit 3, the math of COVID-19. Today we're going to be talking about what your report is and how you find your data. So, COVID-19 is a disease that developed from the virus SARS-CoV-2 or severe acute respiratory syndrome coronavirus 2. And that disease was previously known as the 2019 novel coronavirus. First detected as a pneumonia of unknown cause in Wuhan, China, the virus and subsequently the disease bloomed into a global pandemic over the course of the following timeline from the World Health Organization. First, on December 31st, 2019, the WHO China Country Office was informed of a pneumonia of unknown cause detected in the city of Wuhan in the Hubei province in China. On January 10th, 2020, the WHO issues its first guidance on the novel coronavirus. And on January 13, 2020, the first case of novel coronavirus outside China was confirmed in Thailand. In January, on January 30, 2020, the WHO declared a public health emergency of national concern. And on February 11, they officially named the disease caused by the novel coronavirus COVID-19. On March 7, 2020, there were 100,000 cases reported worldwide across 100 countries. And on March 11, 2020, the WHO characterized COVID-19 as a pandemic. By March 13, Europe, no longer China, was the epicenter of that pandemic. And at the end of March, news organizations began reporting that the United States of America was set to become the new epicenter of the pandemic. National, state, and local governments have responded differently, but all with a singular goal: to flatten the curve. What does that mean? What's this curve we're talking about? Does that somehow tie into mathematics, to algebra, to calculus? Yes, it does. So you're going to explore that. Today, you are a researcher preparing a report on the spread of COVID-19 for a government of your choosing. You can choose a national government, any country you'd like. You can choose a state government here in the United States, or you can choose a city government, a mayor, something like that, looking specifically at one particular city. In order to write your report, you must compare and contrast the spread of COVID-19 in two different populations. Again, these can be nations, states, cities. You may compare two populations that are in similar locations. For example, the state of Tennessee and the state of Kentucky. Or you can compare two vastly different locations, like New York City and the country of Italy. Your report must contain similarities and differences in the spread of COVID-19, as well as recommendations for slowing the spread. So now that you know the purpose of your COVID-19 report, you're going to choose a state, national, or city government that you will be writing your report for. This is your audience. This is who you are speaking to. Sorry, Major Tom's a little excited. One moment, I'll be right back. 15 hours later. All right, sorry about that. Where were we? You're going to choose a national, state, or city government that you're writing your report for. And then you're going to choose one you would like to compare it to. You need to think about why you've chosen to compare these two populations. Is it a random choice? Was there a trend you'd heard of? Be sure that you can explain in detail your choice of populations. So how do you choose? Well, populations can be chosen because they're similar in size, but different in the rate of disease spread. You can choose populations that are different, but are similar in the rate of disease spread. You might choose one population with very few cases and one with many cases, regardless of population type, so that you can make recommendations to one based on what the other is doing. That's a choice for you to make. What would you like to put in your report? Once you make that determination, you need to obtain your data. Now, I've got some rules for you folks. Number one, you have to get your data from a reputable source. Do not use .com or .net websites. Now, can you use .com and .net websites to find reputable sources? Absolutely. They cite reputable sources a lot. You can go on there to look for those citations, but actually go to the cited website, a .gov or a .eu, the WHO, something like that. You want to use that information rather than the way that someone else has already processed and used that information. Also, avoid politicized websites that may be reporting skewed numbers to further an agenda. Just across the board, any article you find, anything that has a political undertone to it, don't use that for purely research purposes. So some places that you can start when you open this document, you can click on these links. The European Center for Disease Control and Disease Prevention and Control. U.S. state government websites are listed as reference numbers in the far right column of the data table of a website I linked here. Now that website itself may not be reputable, but in the far right column of their data table, they've linked their sources, and all of those link to .gov websites with data tables that have real-time data that would be very, very useful for you. You can use the U.S. Center for Disease Control and Prevention. Their website has some good data. And then, of course, you have the World Health Organization situation reports. These probably have the most robust data. You do have to sift through a lot of reports to get those data points. So it's up to you, but those are some good places to start. Now remember, you are studying the spread of the disease. So what you want to focus on are new cases per day. In terms of an X and Y axis, which we'll talk about next time, the number of new cases would be on your y-axis, and each subsequent day would go on your x. Now, once you have your data, you're going to want to create a Google Sheet or Excel spreadsheet to store your data in. I'll be doing examples in Google Sheets, so if you'd like to use the techniques that I'll be modeling, store your data there. You need to have 2 columns in that Google Sheet per population. The first column should have dates in increments of 1 day, beginning with when the first case was reported in your population of choice and continuing through at least April 30, 2020. And the second column should have the number of new cases reported in that location on the corresponding date. Once you have all this information complete, I encourage you to open the Unit 3 assessment and complete sections 1 and 2. All right, I will see y'all next time for section 3.2, finding an equation that fits your data. Have a good one.